Want to
As a cheaper
want to
rate,
make
they're
some
on
announcements
themselves.
before we get started. Gary, you got to quiet down. Darn it. What are the announcements I want to? Oh, the word of the day, for starters, if you want to get credit, is referee.
Referee?
Yeah, that's not for people in the room. That's for people on the outside. Usually, the first meeting of the year we make some announcements. We sort of got our community engaged. We didn't really have time to do that because the first two sessions of the year we had guest speakers, and I didn't want to take very much of their time. But Fatima is much more generous, giving up her time. Not really. A lot of people don't know this. I want us all to be aware sort of what I did this summer. Bill wrote a massive grant. Took the whole summer, was just completely washed out at the end of it for us to try and what's called a T32 grant for fellowship funding, so that instead of having to always beg and borrow and get soft money one way or another, we would hopefully have continuous long-term NIH funding. So hopefully that'll come through, and he deserves a tremendous vote of appreciation for that. He wouldn't tell you that himself, but I want everybody to be aware of that. Kevin wants to make a remark or two as well.
Yeah, so the Allergy Forum is going to be a week from Saturday. We're making last-minute plans. The good news is that the Husky game against USC team is going to be at 4 o'clock.
Oh,
so no excuse for season ticket holders. They're all coming. We'll start at around 8 o'clock on Saturday, be done around 3:30. And it'll be a great meeting, so make sure you sign up. And if you have any questions, let me know. I've got a list, and I know who hasn't signed up yet.
Okay. And then we have two new fellows in the program, and they really didn't get a chance to introduce themselves. There's a large audience who would never meet them, who are outside. And if you guys would just come up here, David, just 1 second so people see your face, and Matt, and just introduce yourself. And then we can go right ahead with Fatima's presentation, which will be prenatal and early life dietary exposures and development of food allergy.
Hello, my name is David Hagin. I completed my studies at the Hebrew University in Jerusalem, Israel. I then spent several years at the Israeli Army. I completed my residency in internal medicine at the Tel Aviv Sorovsky Medical Center. And then I proceeded and did some research at the Weizmann Institute, where I'm supposed to complete my PhD and defend my thesis in the next couple of months. Thank you.
I'm our other less distinguished fellow, Matt Altman. I am fortunate or not related to my dad. And I was out in Boston for the last 8 years. I went to Harvard Medical School and then during that time I did some research at the Broad Institute in systems biology out there. Went over to England for a year to continue that, and then after medical school I went to residency at Brigham and Women's Hospital in Boston in internal medicine, and just finished that up, and I'm very much excited to be out here.
Okay, good morning everybody. Now it's finally my turn. So this morning I have a jam-packed session for you discussing just a very small topic: prenatal, antenatal, postnatal, and dietary factors affecting food allergy. So I'm going to try to get through as much of it as I can, and I promise you'll have a lot of information at the end of it. My slides, you have copies of. There's slight changes that I made just last night, but it won't affect the content, and it's for a review for you to have to look at your leisure. So first of all, no disclosures, no conflicts of interest to report. My objectives for this morning are to discuss the relevant studies that have been conducted with the various factors involved in possible food allergy prevalence, and also to describe their outcomes, if there are any, and how does this relate to you all in your clinical practice. So for starters, let's talk about the prevalence of food allergy. Well, if you look at self-reports, it's anywhere from 2 to 13% for all ages, for milk, eggs, peanut, shellfish, and finfish. But in adults, the prevalence of peanut allergy appears to be 1.3% and 1% for shrimp, 0.4% for milk, and 0.2% for egg, and 1.8% across the board for all of these foods in children between the ages of 1 and 5. The true prevalence, they feel, is very difficult to estimate in the United States because there are still many individuals who have food allergies who have never been formally evaluated and therefore officially diagnosed. So overall, the current report is that the incidence of food allergy in children is now up to about 3.9% in the United States. Over the last few years, there's been an increased number of hospital discharges related to food allergy diagnoses, from 2,000 up to about 10,000. We all know that children with food allergies also have other comorbidities. Up to 40% of children with food allergies have atopic dermatitis, and almost half of them also have asthma. So it's a significant disease burden. So without discussing some basic immunology, I can't proceed with the rest of my talk. So I am giving you this warning right now that I am going to be talking about immunology. So if you need an extra cup of coffee, please go ahead and do so. Question?
Could you define food allergy? What do you mean by food allergy?
I will, because there's different studies and their definition of food allergy is not exactly what we think of as a systemic or local reaction and a positive test. So as it becomes relevant to each study that I'm discussing, I'll define that. So there's a differentiation between food sensitization, which is having a positive test, and then food allergy, which is clinical symptoms with a positive test.
We're going to talk later in the year, I think something like, why do people with IgE antibodies to food not react to them? That's Frank's talk.
Right.
He'll do that well.
Well, I think that's a
Because
pretty
I've never
important
understood
yeah.
that answer.
Yes, and that is a very great question, Mike, and it will be relevant in some of the studies that I'm discussing. So basic immunology, we all know the basic compartments, the innate immunity, which is present from birth. It's a stereotypical response to preserved molecules and pathogens. And it consists of our epithelium, dendritic cells, our phagocytes, complement, and NK cells. And then we have our adaptive or cellular immunity, which primarily consists of our T and B cells. So I want you to focus more on the innate immunity, which consists of our mouth, our mucosa, and our salivary glands, and more importantly, our gut, with gut-associated lymphoid tissue, also known as MALT, mucosa-associated lymphoid tissue. And I want you to keep those two in mind as it pertains to a lot of the studies that are important in understanding the immune mechanism in infant allergies. So how does the immune system develop? Well, they found that fetal IgE production begins at 11 weeks gestation, primarily in the liver, and then by about 21 weeks gestation, the lung and spleen kick in and take over. The Peyer's patches in the gut mature by about 19 weeks gestation, and T cells are present there by 13 weeks. Dendritic cells are present by about 17 weeks. And what's interesting is that they found that the epithelial lining of the gut in the fetus has FC receptors present there. So with those FC receptors, what they've noticed and found through research is that there's maternal IgE that's present in the amniotic fluid. A baby starts to swallow amniotic fluid at about 10 weeks gestation. And with the FC receptors present in the gut lining, they feel that this may be a pathway for fetal priming for IgE antigen sensitization. What about IgG? Well, IgG is being transferred in trace amounts to the fetus via the placenta, but really starts to increase at about 20 weeks gestation, with the maximal amount of transport to the fetus at about 32 weeks gestation and onwards. So if you look at this figure, it shows you the purple dashes are placental and breast milk IgG transfer. And it primarily peaks closer to delivery and then falls off. And then, as we know, the child's IgG production starts several months later after birth. So they feel that there is an IgG and IgE ratio that may be important in the development of later food allergy in the infants that are prone. There's actually an interesting study where they looked at women who were exposed to birch pollen during birch season, and they found that if they were in the height of birch pollen season towards the last 2 months of their pregnancy, their babies weren't sensitized. But if it happened earlier, they were. So postulating that there's this IgE-IgG balance that may swing the developing fetus one way or another. They found that fetal cells can mount an IgE antigen-specific response, and that can be seen as early as 23 weeks. They looked at peripheral blood mononuclear cells, and they isolated those and tested the allergen response, and were able to see that. They've also found CD45 RO positive memory cells in the fetal blood and spleen as early as 14 weeks gestation. And one interesting observation by Holloway's group was that they found the presence of house dust mite allergen in amniotic fluid by about 16 weeks. So again, this is theorizing that there may be sensitization that occurs in utero. So whatever mom is seeing, and that's why a lot of the studies that look at high-risk infants, they have maternal history of atopy. So whatever mom is seeing, the baby is seeing via the gut FC receptors. So at birth, they found that the infant has primarily Th2 dominant responses. And there's an interplay between Th2 and Th1, and how that balances out the ratio determines what we end up seeing as far as a disease state in these infants. So if you look at this graph, you'll find that children who later become non-allergic and children who do develop allergies, they both start off with pretty high levels of Th2 responses. But for some reason, in the non-atopic children, those Th2 responses are dampened and balanced out, and Tregs take over. But in the allergic group, whether they maintain their allergy or eventually outgrow them, they remain high. So they're theorizing that this may be due to the ratio of IgE to IgG, as I just mentioned earlier, but this could also be related to when the child was exposed to the antigen, where I refer to the study with the birch pollen later on in the pregnancy versus earlier on, or even the dose of the antigen exposure. There's a mouse study that they did where they looked at different doses of egg protein and found that there was a certain dosage above which it was seen by the mice pups, and they generated an allergic response to egg exposure later. Or is this something that's also affected by the developing gut flora once the baby is born? And I'll refer to that a little bit later in my talk as well. There was one interesting study that I read, though, that looked at children who developed egg allergy, and this they defined as clinical history of symptoms on egg ingestion plus a positive skin test. And this was at a year of age, they were found to have lower Treg responses and lower Th1 responses when they looked at their cord blood compared to non-allergic children of the same age, which was pretty interesting. So what about toll-like receptors? There's a lot of new information coming out about TLRs. So this study by Prescott looked at mothers who had an allergic history. Didn't have to necessarily be food, could be allergic rhinitis, for example, or asthma. And they found that their infants had elevated levels of TLRs at birth. This graph actually shows in black the children who ended up developing allergies. They looked at their TLR responses and found that they were increased compared to non-allergic children. So at baseline, children of allergic mothers have high TLRs, but those that develop allergies have even higher TLR responses. Specifically, TLR 2, 4, and 5 were noted to be important. Also, another note was that TLR function can be affected by maternal smoking status, breastfeeding, and also unchained polyunsaturated fatty acid consumption. And there's more in the talk about that as well. So there's a complex interplay of many factors, dietary factors, vitamins, genetic factors, and then what's happening in the fetal immune system development in utero, and then what about the diet of the baby after birth. And what I'd like to do is focus on each of those and discuss the relevant studies, what they show, and summarize that in the end with what that means for us in practice. So let's talk about maternal diet. So there's been several studies. This table gives you a list of studies where they had a group of mothers who avoided highly allergenic foods such as cow's milk, egg, or even fish, either during pregnancy and during lactation, versus the group who had no dietary restrictions. And across the board, what they found was that there's no difference in the incidence of food allergy or food sensitization with either of those groups. This table summarizes the studies in which they actually did not have an intervention group. They basically looked at what mothers ate during pregnancy or breastfeeding or growth, and whether there was something in particular that made one group have children with more allergies versus another. Now the caveat with this table is that if you look at the testing, Frank's group only looked at sensitization. So these individuals, the children, were tested by serum IgE to peanut, milk, and egg. And if they had a positive IgE level, they were considered positive, but there is no clinical history whatsoever of a reaction. So these were actually kids that were sensitized, but we don't know what that means. The only two studies on this table are by Desroches's group, where they actually recruited truly peanut allergic children. They were peanut allergic by clinical history of reaction. They had a positive skin test, and some of them they even had oral challenge data on. So these were truly allergic. And what they found was that consuming peanuts during pregnancy or breastfeeding in both of these studies showed an increased risk of peanut allergy in their children. So I think those are probably the two more relevant studies as far as what we're looking for. And if you look at Nawaro's study, it's actually pretty interesting because although they looked at just sensitization by specific IgE testing, they found that the women who ate more citrus fruits had a higher incidence of allergic rhinitis in their children, and those that had a decreased level of vitamin D consumption had a higher incidence of food allergy, but in this instance it's sensitization based on RAS testing. Matt?
In those two studies, the dietary history, that was just a dietary recall.
These are all questionnaires, yes, recall. So each of these studies, they all had the same methodology. It's just their testing, their results, and their sample sizes that were different.
Fatima, I should have asked this earlier, but going back to some of the earlier stuff, what's the logical downstream association of the TLR expression in the development of food allergy? Why didn't anybody look at that? What is the thought process?
They're still trying to figure out how this actually relates to food allergy. It's an observation right now, but they need more research to figure out what's this mean and why is it relevant. And
well,
some
in
of
the
it,
paper, they must have put out a postulate of why they bothered to look.
I don't remember reading why they postulated, why they were looking. I think they were trying to figure out if there's any innate differences. I think the primary motive of those studies was, is there an immunologic difference? Instead of trying to figure out what does this mean, I think it was an observation they found, but really don't know what it means yet. Hope that answers your question. Okay, so what about polyunsaturated fatty acids, omega-3 and omega-6 fatty acids? There is some literature out that talks about supplementing maternal diets, and as you know, DHA and EPA, there's supplements that women can take during pregnancy and during breastfeeding, and also formulas are now supplemented or have that added to them. So what they found is that Western diets, there's far more prevalent consumption of omega-6 fatty acids than omega-3. And what omega-6 fatty acids do is they help arachidonic acid conversion into eventual PGE2. So this may take you back to last week's talk, which then eventually increases IgE production and an elevation of inflammatory cytokines that are seen, IL-1, 2, 6, and TNF-alpha. Omega-3 fatty acids actually competitively inhibit arachidonic acid metabolism to eicosanoids and prostaglandins, and therefore are anti-inflammatory and beneficial. What they also found is that omega-3 fatty acids increase IgA secretion in breast milk, which is important for oral tolerance in babies. So there's a study where they looked at about 700 women and they divided them up into allergic and non-allergic mothers, and they supplemented them, or actually they studied their diet in this one. I'm sorry, I'm thinking of the next study. They looked at their diet and found that those women who ate fish more than once a week during their pregnancy, in the non-allergic group, their children actually had less incidence of food allergy. And this was what they defined allergy was just positive serum IgE testing. To cow's milk, it was 6-fold less in that group and 10-fold less to egg. But this was only a benefit seen in the non-allergic mothers, which was pretty interesting because you would think that those with a family history would be at higher risk.
Did they have that group? That's the group that counts.
Mm-hmm. They studied both. They divided the women up into those who had allergies and those who didn't. But this benefit was only seen in the non-allergic mothers' children, not in the group with allergies. So it was not what you'd expect. So are PUFAs beneficial? There was another study in about 700 women where they were given fish oil capsules, and the DHA dose was about 800 milligrams. And all they found that it was reducing the incidence of atopic dermatitis, but it didn't really have any effects on food allergies. And there was another study that Durantis did, and that one Dunstan did, and that one also supplemented fish oil capsules, but the other group did not receive anything. They received a placebo in its place. And they found that it actually reduced the incidence of a positive skin test to egg by 3-fold at age 1. But they used about 3.7 grams of fish oil per day, which is the equivalent of 1 fatty fish meal per day. So with this study not finding any effect, it may just be that the dose of the omega-3 fish oil may not be enough, and we don't know what that dose actually is. So is this beneficial? We still need more research to figure that one out. So what about vitamin D and antioxidants? Briefly recall the Navarro study that I presented earlier on maternal diets. They found that women who were consuming less vitamin D actually had a higher incidence of food sensitization. But vitamin D is also important in our function of our T cells, B cells, our dendritic cells, and our epithelial cells. And they've shown studies that supplementation may induce immune tolerance, and we definitely know there's studies about vitamin D supplementation in wheezing and asthma development in infants where it actually reduces the incidence of that. So we seem to not be able to get away from vitamin D in our talks either, but we still need more studies and more research to determine if this is truly beneficial in the food allergy realm. What about antioxidants? Well, Western diets are low in antioxidants and vitamin E-rich foods, and what they've shown is that antioxidants help affect Treg function and promote Th1 responses. So it may be beneficial, but we don't have enough information yet as far as whether this should be a supplement that women should take during pregnancy. So again, more research needed. What about fiber? Well, we also don't consume enough fiber in our diets as well. And there was an interesting study that talked about gut flora, our normal gut commensal bacteria. They actually ferment the fiber that's undigested in our intestines and produce short-chain fatty acids. And short-chain fatty acids have been known to have anti-inflammatory properties. So this may be important in gut immune tolerance promotion, as I mentioned earlier in the talk, in infants. There's a mouse study where they actually looked at mice that had a knockout of a specific protein, so they had no gut bacteria, and they exposed them to allergen, and they looked at their alveoli and found that the control mice had normal alveoli, but the ones that were knockout had significant inflammation. So they feel that short-chain fatty acids in the gut may be beneficial. But again, more research is needed in this arena as well.
It's a knockout of what?
It was a knockout of a GPR43 protein that they found was necessary in the gut for bacteria to colonize. So these mice had basically no bacteria in their colon at all, and they had lots of inflammation. So what about probiotics and prebiotics? So there's a study that looked at maternal supplementation of probiotics about 2 weeks before delivery, continued with probiotic supplementation of the mother during breastfeeding and the infant until 6 months of age. And they found that it was the lactobacillus species that was beneficial, and it actually helped with immune tolerance. It increased IgA production, it increased IL-10 production, and decreased TLR4 responses and TNF-alpha. So what they found was that it had an improved outcome with regards to atopic dermatitis, but there's really no effect on food allergies. And the same was true with prebiotics. So there's more research that's needed in probiotics, but the thought is that it modifies your gut flora, so therefore may be helpful in food allergies, since there's a lot that's being mediated through the gut in the developing fetus and then the infant with regards to tolerance versus sensitization.
That supplementation was only 2 weeks before?
Mm-hmm. They started 2 weeks before delivery and continued while mom was nursing, and then the baby, once the baby was born, started getting probiotic supplementation.
But not earlier in pregnancy?
Not earlier, not in this one. So they're doing more studies looking at that. So how about the maternal environment? Let's focus on that. So there's 2 Jackie studies that talked about the effects of growing up on a farm. And they studied farming mothers in Austria and Finland and the Netherlands. And both studies had the same group. It was like 1,100 or so babies. And they measured their cord blood IgE at birth and at 2 months of age to egg, cow's milk, peanut, wheat, soy and hazelnut, and carrot. And what they found was that they also studied inhalants as well, which is why you'll see that. But I'd like you to focus on the bottom graph. The black bars are the infants that were farm raised. And what they found was that these infants had higher IgE levels at birth and also at 2 months of age to these foods. But again, there's no history of clinical reactivity in these children. All we know is that they have high IgE levels, so they're sensitized, but what does that mean in clinical practice? We don't know. There's a second study that just came out this year, 2012, in Jackie. It's the pasture study. I don't know if you guys saw it, but it looked at farm-raised children, and they found that the TLR responses were elevated at birth and then a certain period of time after birth as well in farm-raised kids versus regular city kids. But again, we have no information on what that means clinically because there's no information on reactivity, whether they eat the food, tolerate it, and so forth. But an interesting observation. So what about where you're born? There was this study by Keith's group that looked at the incidence of food allergy, but food allergy in this group was also defined as IgE positivity, so it's actually sensitization. And they studied peanut, egg, and cow's milk, and they found that children who were born in the United States had a far higher prevalence of food sensitization compared to children who immigrated to the United States when they were less than 2 years of age versus children who were older than 2 who immigrated to the US. So this graph shows you the proportions of each of those groups of children who are sensitized, and I'm looking for my cursor. And the blue bar is the US. Well, this whole graph is the US children, but this is any food, and then they looked at each of the individual foods as well versus foreign-born. So they feel like there's something in the environment when you're born outside of the United States that's protective, but as long as you've spent at least 2 years in that other country. So maybe that's environment.
What was the breakdown of the foreign births? Where were they from? I mean,
they reported them as Hispanic, non-Hispanic, African American, and other. There were 4 groups, and that's all we know.
they're pretty equal, or?
Yes.
Did they stratify for if they came from a farm community or something?
No, they did not look at that. They did not look at that at all. This was a study where they actually looked at reporting data that was from a big statewide survey. I believe they did this in New York, if I'm remembering correctly. And this was the same study.
Did they comment on why peanut was different than cow's milk and egg?
They made no comments at all as far as why one food was different than the other. They just looked at food sensitization in general, and the only comment they made was that they postulated that a higher IgE level meant that they were likely food allergic. But again, this was all a retrospective survey of a population of about, I don't have the number, it was believed, did I put that in there? 3,500 children under the age of 21. So this is all a review of charts and online EMRs. That's how they conducted this study.
They also mentioned data for kind of what I'd call the controls. In other words, how about those foreign people that never move? Like what's the baseline?
Yeah, they didn't have any
I guess
data.
there might not have been enough of each of the individual groups.
Right. The population, I think, was skewed towards primarily Hispanic as far as the nationality, but they had only the breakdown of the 4 groups. And they did not look at people who were in other countries. But we already know as far as prevalence rates, they went with that knowledge that the United States has a higher prevalence of food allergy, especially compared to some of the countries that their population is coming from, like some of the Latin countries and so forth. And Africa, for example, has far fewer food allergic patients compared to the United States. So this study, although interesting, really doesn't help us because it just looked at, again, sensitization, but not what's happening clinically. And this bar graph actually shows you the significant differences between people born in the U.S., whether they were of foreign heritage or Caucasian heritage, still higher proportions of food sensitization versus children who immigrated at under 2 years of age versus older than 2. So what about moms who smoke? Well, we already know smoking is bad for you. It causes low birth weight, prematurity. It increases the risk for development of asthma in children, infections such as otitis media. There's learning disabilities and heart defects that are associated with it. It also affects TLR function and placental function. But there was one Finnish study that looked at about 16,000 mothers, and they just looked at their dietary practices, delivery, how the babies were delivered, and smoking status. And they found that actually the moms who smoked, they had less cow's milk allergy in their infants. And they actually defined cow's milk allergy as not only having a clinical reaction, but a positive skin test. And they challenged these children as well. And they were positive on oral challenge. So these are truly allergic kids. So I don't know, maybe they were smoking natural organic cigarettes like you can get on Capitol Hill, but this was the only positive effect I have ever seen with smoking other than for Crohn's disease. So let's talk about infant feeding and breastfeeding. Let's see, I think I'm okay so far on time. So the next two slides actually summarize some very interesting studies with regards to infant diet. So the first one, Zudavern, there's about 2,000 children, and they looked at delaying introduction of solids past the current recommendation of 4 to 6 months. And they found that by 6 years of age, there was increased food sensitization. So this was just looking at either a positive skin test or a positive serum IgE. Copland's group looked at about 2,600 infants that they defined as high risk, having a family history of atopy. And they defined allergy in these infants as having a positive clinical history of reaction to egg consumption, a positive skin test, or if they had no clinical history but had a positive skin test, they underwent an oral challenge. And if they had a positive oral challenge, they were included in this study. And they found that those children who had the egg allergy, they had a higher incidence of egg allergy when they had a delayed introduction of egg past 10 months of age. And this was a study, I believe, in Australia, if I'm remembering correctly. And then Navarro did another study that was published in Pediatrics in 2010, which also showed that delaying introduction of egg increased the risk of egg allergy by age 5 years. And Joseph looked at sensitization, so just a positive test to egg, cow's milk, peanut, in those individuals that had a family history, and in their group found that when kids were introduced solids earlier, younger than 4 months, and specifically to those foods, they actually had a decreased level of IgE. But we don't know what this meant clinically because there's no history of whether they tolerated those foods or had a reaction. And then the last study was actually the GINI study, which is the German Infant Nutritional Intervention Study, and the LISA study. And these are all children with family history of allergy. And they found that delaying introduction of solids really didn't do anything for either food sensitization, which is a positive test, or actual allergy within the first year of life. So, so what do we take from this? I will summarize all of this. I know I'm presenting a lot. So we're left with more question marks. I thought about putting question marks on each of these slides at the end, but I didn't because when you got your copies, you have these big question marks in like half the handout. So this study is actually very interesting because it looked at peanut allergy rates in Jewish children in the UK versus Israel, because they found that there's a much higher prevalence of peanut allergy specifically in the UK, tenfold higher versus Israel. So this was a questionnaire conducted in school systems in the UK and Israel, and they surveyed a total of about 8,800 children. The two groups were very similar as far as demographics, socioeconomic status, history of atopy, family history, etc., etc. And these were all children who were truly peanut allergic, and that was defined as having a positive history of reaction to peanut ingestion and a positive skin test, or a positive skin test with a positive oral challenge. And what they found was that the only difference between the two groups, and they assumed genetically that the two groups were similar, the only difference was the age at which peanut was introduced to children in Israel, and also the amount of peanut consumption in Israel. This graph, I know it's busy, but what I'd like you to focus on, it shows the ages of introduction of the different food groups: peanuts, tree nuts, sesame, eggs, milk, soy, and breastfeeding rates and weaning. And they found that they were very similar except for peanut. About 69% of children in Israel had consumed peanut by the age of 9 months, and equally higher rates of consumption and earlier introduction of sesame in children in Israel. Also, they found that mothers in Israel tend to consume peanuts regularly when they're pregnant as well as breastfeeding, compared to mothers in the UK. And the number of snacks that children in Israel get is about 2 peanut butter containing snacks per day. So as far as amount of peanut consumed, it's much higher. So they use this data to theorize that early introduction of peanut is actually beneficial and reduced the risk of peanut allergy.
Is there any difference in how the peanuts are roasted or other things between the
I didn't feel there was a difference between Israel and the UK with processing of the peanut, but I know that is an issue in other countries. And I have a slide at the end where I kind of mention that as well.
Can you go back to that slide?
Uh-huh.
That slide, like that peanut, is that just showing us the percentage of kids who consume peanut, or
So
is it showing
it's-
the incidence of peanut sensitization around?
No, it shows age of introduction of each of these foods. So the blue lines are children in Israel, and the red is UK. So they start consuming peanuts maybe around 4 months, and then they just increase their consumption.
So where's the data on the actual prevalence of peanut allergy?
I didn't put it up in the slide, but the actual prevalence is about 1.8% in the UK and 0.17% or something like that in Israel.
That's cool.
Yes, it's a tenfold difference. So I just stated that in my talk, but didn't put it up in the slide, but it is stated in this article.
They don't grow peanuts in Israel, do they?
I don't think so.
They all come from Georgia?
Huh? Since Jimmy Carter went there, they grow peanuts?
It's somewhere in
They do
somewhere
grow
in
peanuts in
America.
Israel?
So whoever gets the peanut capital of the world, please see Dr. Altman for their prize.
Isn't there also a difference in cow's milk allergy between Israel and like Germany?
So, well, in this study, they didn't find a difference in introduction of cow's milk between the two, a significant difference between the two groups. But as far as the rates of cow's milk allergy between Israel and Germany, I don't know those.
I remember there was some sort of controversy between the two, where the Germans didn't replicate the Israeli data, but
Which
I didn't.
just that it was the introduction of cow's milk.
I don't know if the introduction of cow's milk is different in Germany versus Israel. They just compared children in Israel to.
Yeah, I think it's another set of studies.
Yeah, and I don't think I read those.
They talk about sort of approximate amounts of peanut that these kids were eating. I'm just curious because you have to think with a lot of this amount matters as well as.
She said that
They said it was the equivalent.
Two,
They were
okay.
getting about 2 peanut butter snacks every day in Israel versus not. And they did have some theories as to how many grams that would equate to. And I don't remember that number. But I do remember the 2 peanut butter snacks per day.
Do any of these studies comment on the fact that they're sort of reversing everything that's been dogma for the last 100 years? Is that you should give them peanuts earlier instead of later, and you should introduce a solid food before a year? I mean, this is exactly the opposite of what we've all been trained.
It is the opposite, but I think that the recommendations as far as diet might change in the next few years because they are talking about maybe we should be introducing some of these foods earlier than we currently do. And there's an article by Prescott's group, and she was the lady that gave the talk at the Food Allergy World Allergy Forum at the Quad Eye. She's from Australia, where she actually said we should be conservative and not do this because we don't have enough data yet. So it was a pro and con article. It was in Jackie. It was very interesting to read. So yes, this contradicts that, but we may be moving to that at some point.
Why have the recommendations been for so long to avoid introducing these?
So the recommendations for foods, introduction of foods, have been based on when they thought the infant's gut was mature enough to handle those proteins. And they've kind of stuck with minor adjustments here and there, but these are studies that are showing that maybe we should be changing practices, because in other countries, the way they feed their children, what they feed them as their first food is quite different. For example, in Africa, they get meat as their first food, whereas here we recommend rice cereal. And fish in Asian countries is one of the first foods, and we think of that as highly allergenic. But you don't see the same rates of food allergy in those countries as we do in the US. So why is that? So still a lot of questions that are brewing about based on the patterns that we're seeing worldwide.
Now, to answer your question, they were just made up. The 2000 consensus was expert opinion, so it's level D evidence. And so I think there's a demand for tell us what to do. And so they just said, look, let's just go that way. Now in 2008, it's gone the exact opposite direction. So we're actually, that ship has sailed. We're already saying, give everything, whatever.
All right, so what about breastfeeding? So we know breast is best. And what we have is, again, I'm going to summarize some of the studies that I found. Actually, it's more than 2 studies, but this table basically shows you an interventional groups where infants were either fed breast milk or they were fed a cow's milk-based formula for about 4 months. And what they found was just a decrease in the incidence of atopic dermatitis in the breastfed group. Their food allergy status was based on having a positive clinical history. And this was cow's milk allergy, by the way. So positive clinical history of a reaction to cow's milk. They had a positive skin test, and they were also challenged and had a positive oral challenge. And all of these children also had atopic dermatitis. So beneficial to breastfeed. Well, what about feeding practices? I'm sure you've all heard about Alicia Silverstone and her bird feeding of her baby. So is this something that is beneficial in reduction of food allergy? Well, I'm interested in learning if her child develops food allergies later on in life. But so there's countries where pre-masticating food is common practice among mothers to their infants. So are they using their salivary enzymes and digesting proteins into less allergenic proteins and giving that to their baby? Or is it salivary IgA that they're transferring to their babies that's helpful? Or is it just all the bacterial load from the mother that the baby's getting, so the gut is now busy processing the bacteria and is not really thinking of producing these aberrant allergic responses, and therefore, is this all helping with oral tolerance? Who knows? But interesting. So we go back to the gut again. That's kind of my theme of the talk. So if you recall last year, I had my journal review session, and this was the iPood set of slides that I did not get a chance to get to, and Paul had asked me about them. And I thought I'd bring these back because this was a study that actually looked at the prevalence of atopy in children based on how they were delivered, where they were delivered, and then postulated that their GI flora was implicated in this. And just to be brief, for the sake of time, what they found was that a change in the GI flora to an abnormal non-commensal flora, for example, C. diff colonization, was changing their immune tolerance. So you didn't have the Treg cells developing, you had more of a Th2 response. And they found that with the C-section babies. So this was a cohort of about 2,700 kids, and they actually did fecal samples at 1 month of age for various bacteria, and then they measured their IgE levels to egg, peanut, and cow's milk at 1, 2, and then 6 and 7 years of age. And what they found basically was that children who were delivered vaginally and at home had the lowest incidence of eczema and food allergy at 6 to 7 years of age. And C. difficile colonization actually increased this prevalence. So, is there a role for the gut in the immune system? Well, I feel that there is. This was another study that looked at delivery and the prevalence of food allergy, specifically cow's milk allergy. And they defined allergy to cow's milk in this group by not only did they have a clinical history of a reaction to milk, but they had a positive test. And if they had a positive test but no history, they were challenged, and they had a positive challenge. So these are truly cow's milk allergic kids. And they found that those who were born by C-section had a higher incidence of cow's milk allergy. So how about how food is prepared? A question, or actually comment, that Dr. Henderson so wisely pointed out. Well, is it how we're preparing our foods that's leading to the increased incidence of food allergy? Well, we know that peanut is roasted here in the United States, and that increases its allergenicity versus boiling it in other countries where they don't have as high of a rate of food allergy. Who knows? We don't know if that's one of the factors, but it is in the pot, in the mix. So I've gone over a lot of information with you this morning, and it's a complex interplay of multiple factors. So is it what's happening with the fetal immune system development in utero, and what antigens the baby is seeing in utero? Is it where mom lives, or what mom is doing? Is it what mom is eating when she's pregnant? Is it what she's eating when she's breastfeeding? Or is it what the baby is eating later in life? Is it how the gut flora develops, or is it other nutrients that we are or not getting, or pollutants? It's hard to say. I think what this will end up being is a complex interplay of all of these factors, or some of these factors, where some will be more relevant in a certain individual versus another. So this is actually going to be more personalized medicine, where I think it's not going to be one answer for everybody. So with that, what's the future in research? Well, we've all heard about the filaggrin gene defects associated with atopic dermatitis, causing leaky barriers of epithelium. There's implications that the filaggrin gene defect is also associated with eosinophilic esophagitis, and they found that the epithelial junctions in the esophagi of these patients were leaky. And there's also some data that the gut epithelium in infants with food allergy is leakier than those that are healthy. Even after you eliminate the food that they're allergic to, it doesn't restore to normal. So maybe that's what's playing a role in food allergy. So there's more studies that will be on the horizon with filaggrin gene defects. What about TSLP, thymic stromal lymphopoietin? Well, it acts like IL-7 and drives Th2 differentiation, and there may be more on the horizon with that. There's some reports that using antacids in children is increasing the development of food allergy. And in 2013, there's going to be a peanut allergy study in the UK that's out. It's called the LEAP study, and that's their website. So it'll be interesting to see what data comes from their group. And there's the Human Microbiome Project. They feel that there's thousands of species of bacteria that colonize our gut that we aren't ever able to see because we can't culture them out. They don't grow in culture. So they're going to identify all of those by, I believe, PCR mechanisms, and that will come out at some point. So who knows how many they'll find there. So in summary, what does this mean for all of you guys in practice, what I've just told you about? Well, it brings us back to the NIAID guidelines that came out in 2010. It's a 58-page document. I've read all 58 pages, just to let you know, the Cliff Notes version, you want to look at pages 33 to 36. And I've actually put these in my next slides, and I've highlighted the major recommendations. So they don't recommend avoiding foods that have cross-reactivities in children or in people at high risk for allergies. They feel that there's not sufficient evidence. What about maternal diet? They don't recommend moms restricting their diet during pregnancy or breastfeeding. There's not enough evidence. Breastfeeding, they do recommend exclusive breastfeeding if the mom is able for at least 4 to 6 months. And if they want to go longer, that's fine. There is attachment parenting out there, and I was going to put that slide up from Time, the cover of Time magazine, but then I didn't because I didn't know how the audience would take that. But who knows if you go longer than a year, if that's protective, but at least 4 to 6 months. They don't recommend using soy formula to prevent cow's milk allergy incidents in parents who want to use formula. It's not shown to be beneficial. Hydrolyzed formula, though, in high-risk infants for cow's milk allergy, it has shown to be beneficial. So if they're going to supplement or exclusively formula feed, you can use these. They don't recommend delaying solid introduction past 4 to 6 months. And I hope I have given you enough food for thought this morning.
We have one question typed in to us here, since there's such inconsistency here. Someone asked a question if it had to do with chlorination of the water. I don't know how you're going to comment on that, but...
Well, you know, I think that there are countries where clean water is an issue, and those children have severe GI illnesses. And it makes me think of actually the African countries, and you don't really see a higher prevalence of food allergies in Africa. So chlorination specifically, I don't know. But maybe kids should be eating salmonella-tainted peanut butter. Maybe that'll help. I don't know.
You know, Fatima,
Yes.
the 2010 guidelines were based on the 2008 American Pediatrics guidelines, and it's really shocking how many primary care doctors are still recommending strict avoidance of various foods.
Yes.
And it's funny, they've taken it sort of as dogma, something that was very weak in the beginning, and so I find that I have to contradict a lot of other doctors when I give recommendations, and that's really an odd state to be in.
Right. Well, I did primary peds for a while, and I looked at all of this data because I would get asked that by parents, and I would tell them there's no data that you should give it earlier, and there's data that giving food later is bad. So I would say between 4 and 6 months, and that's still true to this day. So we are in a difficult position, but if you use the guidelines to help support you and talk to your patients, I think they understand where you're coming from, but it is confusing for them to hear two opposite recommendations.
It's interesting to speculate on what would happen if you took pre-masticated food and used it for skin testing.
Well, you might want to make sure their immune system is intact because it's got a lot of bacteria.
I sort of have two questions. Is the incidence of food allergy still significantly higher in the U.S. than all these other countries, number one? And number two, have any of the formula manufacturers started to supplement their formula with bifidobacteria or any of these probiotics so that the babies get it right at birth?
So to answer your first question, actually the prevalence slide that's in your packet, there's a peanut incidence that was quoted as 0.6% in the U.S. versus 0.06% in the U.K. So just from reading all the articles that I've read, I don't have exact numbers for other countries, but we do have more food allergy in the U.S. than other countries. Even the UK, if you look at the 10-fold.
So that statistic is still valid that we're way worse than other places.
Mm-hmm. But there's the newer, at the talk that I was at last year at the Quad AI, they were saying that developed countries where they were westernized, they were picking up their rates. And I think somebody told me in Germany after the wall, I don't know, Frank, maybe if it was you, after the wall was broken down, the rates of food allergies normalized between East and West. Someone told me that as an aside. I don't remember who it was. And then to answer your second question, I have seen formulas with probiotic supplementation in it. But as a caveat, you want to make sure your infant is not immune deficient to get those. Otherwise, that would be bad news.
Fatima, the farm maternal diet slide, I thought I was under the impression that the farm-raised kids had less IgE, but yours said have more.
They found that they had more IgE and higher TLR responses, but it didn't say anything about what that meant clinically.
Yeah.
And we know that being raised on a farm decreases the incidence of allergy.
Decreases.
Decreases respiratory allergies.
But the IgE levels were still higher. That's what.
Yeah, they were higher, but it just maybe the exposure was greater. And they even measured, there's some talk about measuring the distance that moms lived from dung hills and how that factored into allergy. I mean, there's some interesting stuff out there when you
It
search.
also raises the question, when you said allergy is both a clinical reaction and a positive test,
Mm-hmm.
we didn't make the distinction between whether that clinical reaction is eczema or anaphylaxis, which is a big difference. Why do some people just get a flare of atopic dermatitis from food and other people have anaphylaxis? And what was their definition of a positive reaction? And that'd be another journal club topic, why some people with food allergy get eczema and don't get systemic anaphylaxis. So do they make that distinction in these papers?